Hi, math friends. Today we're looking at geometric vocabulary. Our focus is only on the vocabulary for today, so we're going to be taking a lot of notes, doing a lot of writing. All right? So let's look at point. To start, point specifically is described as a location in space. It has no size or shape. And the way that we show a point is by drawing a dot or drawing a point, and we put a letter next to it. So this we would call point C. Let's look at line. All right, so line is a straight, continuous arrangement of an infinite number of points. It has infinite length, but no width. So how do we show a line on here? Well, we're going to draw a line with arrows going both ways to show that it could go on forever. And we'll make 2 points on it to show what line it is. Or we could do 1 point. This could be line A, or if I have another point over here, this is how we typically show it. This could be line AB. Let's look at a plane. This one can be kind of confusing sometimes. I think of a plane as like a sheet of paper. The technical definition of it is a flat surface. It has infinite length and width, but no depth. So think of like a sheet of paper, but not having any thickness to it. So it's very conceptual. Typically, the way that we show a plane can be with 3 points, or it might just be like drawing a figure with a letter inside of it. So it's not making a point for it, it's just saying this is plane Q. And it's typically an uppercase letter. All right, let's look at some more. So we have line segment first here. Line segment is a portion of a line that includes 2 points and all the points between those 2 points. So if I'm drawing a line segment, I'm going to just draw a segment of it. I'm not going to show arrows that it goes on forever. So this would be line segment CD. So it contains everything between C and D, but we can just call it line segment CD. The way that we can write that is like this. All right, endpoints, you already see them on this line here. The endpoints on this line are C and D. Specifically, it's where the line segment ends. And we already showed those here. For this example, it's C and D. All right, array. So array is next. Array is similar to line segment. It's going to be a part of a line that begins at a point and extends infinitely in one direction. Okay, and array would look like this. And array might even be denoted with a letter. So I'm going to put some different letters here. We'll say CE. So this would be ray CE. And the way that we show it is by drawing a ray above those 2 letters. So this is how you would write it if this was on your paper. All right, let's look at angle. So an angle is formed by two rays that share a common endpoint. Yep, let's go ahead and draw that. So this endpoint is A. Over here we have B. And over here we have C. So this could be angle A. Another way to see this, when we start seeing more letters in geometry as well, we take the letter right here. This is going to be at the vertex. That's what's coming up next. We name it with the vertex being in the middle. So this could also be noted as angle BAC. You would trace and follow with your pencil or with your finger in order, leaving the vertex in the middle. All right, so specifically what is a vertex we're going to look at next. So specifically it is the common endpoint the two rays share. So these are technical definitions, and I've also been telling you guys more informally what things are and then drawing what they are too. And we have a few more. We have arc. So an arc is part of a circle. You can think of it as like a curve between 2 points. So kind of like a line segment, but specifically in a circle. So if we take a circle and I look at an arc, it would be like from here to somewhere else on there. So arc AB would be just this part right here. Okay, so congruent is going to be a big term for us too. Congruent means to have the same size, shape, and measure. So everything has to be the exact same. So congruency and proving congruency in geometry is really important. If you have two line segments, and to make sure that these are the same, I'm going to copy this and move it. We may not be able to just see that they're the same. Sometimes we'll have to measure them. So I'm going to call this one AC, and this one I'm going to call XY. Okay, so after you prove that they're congruent, you would say AC, line segment AC, is congruent to, you write an equal sign with a little like a squiggly on top there, is congruent to XY. So after we've proved they're the same, we can write this statement. All right, similar, along the lines of congruent, but not exactly. It means to be the same shape and in proportion to each other. The important thing here is that it's not necessarily the same size. Okay, so if I'm able to draw a line segment, and we'll call this BC. And then if we draw a line segment that's exactly half that size, so let's say this is AD, we could say that these two things are similar. And more so we look at these with shape. So like if BC is the side of a rectangle. So let's extend this so that this is the side of a rectangle. And AD is also the side of a rectangle that's that each side of that is half its size. So then we would say that these two rectangles are similar. And the abbreviation was the symbol for similar is just this top part of the congruent sign.